Hello viewers. In this session, we will discuss about the magnetism. A magnet is a material or object that produces a magnetic field. This magnetic field is invisible but is responsible for the property of a magnet. A force that pulls on other ferromagnetic materials such as iron, steel, nickel, cobalt, etc., and attracts or repel other magnets. Magnets have magnetic field around them. Magnets have two opposite poles, North Pole and South Pole. If a magnet is suspended with a thread such that it is free to rotate in a horizontal plane, it always points itself in the geographical north-south direction. Two same poles repel each other and opposite poles of magnet attract each other. Magnets exert no force on a non-magnetic material. Magnet attracts other magnetic materials by inducing magnetism in them. The power of a magnetic material behaves as a magnet so long it is kept near or kept in contact with a magnet. This type of magnetism is called induced magnetism. The process in which a piece of magnetic material acquires magnetic properties temporarily in the presence of another magnet is called magnetic induction. When iron and steel bars are placed near the power magnet induces magnetism in iron and steel bar. Poles are induced in the bars. When the magnet is removed, the iron loses its magnetism. It was only a temporary magnet. However, the steel bar retains magnetism. It became a permanent magnet. When two magnets are placed with their like poles facing each other, the lines of force are in opposite direction, and hence like poles repel each other. When the unlike poles of a bar magnet face each other, the magnetic lines of force are in the same direction, and hence unlike poles attract each other. Magnetism is a force exerted by magnets when they attract or repel each other. Magnetism is caused by the motion of electric charges. Every substance is made up of tiny units called atoms. Each atom has electrons that carry electric charges. The orbital and the spin motion independently impart a magnetic moment on each electron, causing each of them to behave as a tiny magnet. In most substances, equal number of electrons spin in opposite directions, which cancels out their magnetism. Substances such as iron, cobalt, and nickel have most of the spin in the same direction. This makes the atoms in these substances strongly magnetic. To become magnetized, the magnetic substance must be kept inside the magnetic field of the existing magnet. The magnetic field is the area around a magnet that has magnetic force. Magnetic force is the imaginary lines surrounding any magnet. How magnets are formed? The first method is induction method. Placing a piece of steel near a magnet makes it permanently magnetized, but its magnetism is usually weak. The second method is stroking. Ferromagnetic substances are magnetized more strongly by stroking it with one end of the magnet. Internal micromagnets align in same direction and thereafter become saturated. Here, saturated means it cannot be magnetized anymore. Finally, poles are induced in the ferromagnetic material. It became a magnet. The best way of magnetizing is to place the steel bar in a long coil of wire and pass a direct current through the coil. The coil has magnetic effect, which magnetizes the steel bar. If a magnet is broken in half, each half will behave as magnet. The magnetic poles are always in pair. Magnetic field lines are imaginary lines. These lines are along which not magnetic pole would move. In a bar magnet, the magnetic field lines look like this. Magnets have an invisible field made up of lines of force. These lines of force are from north to the south pole of the magnet. Field lines are unaffected by non-magnetic materials, but become more concentrated when a magnetic substance like iron is placed in the field. We have understood how magnets are produced. Let's also understand what happens inside the ferromagnetic material, how magnetism happens at atomic level. In an unmagnetized material, the tiny electrons or atomic magnets points in random directions. When the material becomes magnetized, more and more of the tiny atomic magnets line up with each other. Now, the spins of electrons are acting in same direction, and they act as one big magnet. The demagnetization means destroying the magnetism. In the first method, if a magnet is hit with a hammer, the tiny atomic magnets get thrown out of line again. So the material becomes demagnetized. A magnet will also become demagnetized if it is heated to high temperature. A magnet can also become demagnetized if placed inside solenoid which is supplied an alternating current. Magnet attracts ferrous materials such as iron, nickel, cobalt, steel. Materials attracted by a magnet are called magnetic material. Magnet does not attract non-magnetic materials such as aluminum, gold, silver, and copper. Hard magnetic materials are difficult to magnetize, but do not lose their magnetism. Example, steel alloys. Hard materials are used for permanent magnets. Soft magnetic materials relatively easy to magnetize, but magnetism is temporary. Example, iron or mu metal. Soft magnetic materials are used in electromagnets and transformers. Magnetic field is the region around the magnet where we are able to detect magnetic force of the magnet. If a piece of iron is kept far away from the magnet is not able to attract it. But if we bring iron closer and closer, they would come to a point when magnet is able to attract the iron. Magnetic field is the region in which magnets show their properties. If we spread iron filings near a bar magnet, the iron filings are able to align themselves in a different curved lines. These curved lines are magnetic field lines. Magnetic force lines are imaginary lines which start from North Pole and moves towards South Pole. Magnetic field is strongest where the field lines are closest. The magnetic field lines are closer to each other at poles. Thus, field is strongest at poles. We can draw field line with the help of a bar magnet and compass. Place the compass near the north pole of the magnet. Mark a dot with the compass needle points. Now, place compass at the mark and again mark a new dot with the compass needle points. Similarly, keep plotting until you reach the south pole. Join all points. The line formed is magnetic field lines. The diagram shows these key features. The magnetic field lines never cross each other. The closer the line, the stronger the magnetic field. The lines have arrowheads to show the direction of the force exerted by a magnetic north pole. The arrowhead points from the north pole of the magnet to its south pole. When unlike poles are placed near each other, their magnetic fields combine to produce a single field of almost uniform strength. When like poles are placed near each other, their magnetic fields cancel each other, and there is a neutral point where the combined field strength is 0. The behavior of a compass shows that the Earth has a magnetic field. Scientists believe that this field is produced by convection current in the Earth's core, which is made from iron and nickel. When a plotting compass is placed in the Earth's magnetic field, the north pole of the compass will line up with the Earth's magnetic field lines and points to magnetic south. So, the Earth's magnetic field is like that around a very large but very weak bar magnet. Hard magnetic materials are difficult to magnetize, but don't lose their magnetism and use for permanent magnets, whereas soft magnets are easy to magnetize. However, magnetism is temporary. Bar magnets are permanent magnets. Permanent magnets are used in needles of compass, microphones. Magnetism of electromagnets can be turned on or off. When a current flows through the coil, it produces a magnetic field. This field is temporary and is lost when the current is switched off. Strength of electromagnet is increased by increasing the current or by increasing the number of turns. Electromagnets are used for circuit breakers or relays. We have reached to the end of this session. Thank you, viewers, for watching this video. Please share your views in the comment section.
You